Alright, so hello, good day. So welcome to our another video. So in this video, we'll discuss the Module 4, Python User-Defined Data Structure. So in this topic, this one Python provides supports for implementing a user-defined data structure. So some common data structure used in computer science are stack, queue, tree, heap, graph, and many more, which will be the focus of this module. So for this module 4 and module 4.1, we will only discuss 2 for now, and then we'll discuss the C, D, E, and F to the next video or to the next day. Okay, so for today's video, we will only discuss the stack and then the queue. Okay, so the learning objective of this module is to understand the function of user-defined data structure. Second is to identify the different user-defined data structure in Python, and then lastly is to create a program implementing the different data user-defined data structure. Okay, so let us start. So in here we'll define what is this user-defined data structure. So a user-defined data structure is derived and implemented using the built-in function. So to make it simple, this one was made by a user, or you or me as a programmer, and then of course we have our own ways of constructing or doing things. So what important is you yourself as a programmer create that one. Okay, that makes that one as a user defined data structure. So it is used to solve specific problems that requires specific behavior of how data is being stored, and then each user defined structure has its own characteristics. And then last is that set of operations to be performed on the data are also predefined by the system. So all in all, it is made by the user or the programmer with the use of a built-in function. Okay, so it's just that in here, of course, the structure or uh, the code that we're going to create for this one is all about storing a data. So that is why this one is used to solve specific problems that requires a specific behavior of how data is being solved. Okay, so the first one is the stack. So it is a linear data structure which follows a particular order in which the operations are performed. So stack follows the following order. We have the LIFO or the FILO. So either of those two, they are just actually the same. So we have the last in, first out, and then the first in, last out. So you could also see that, you know, uh, whoever comes first will go out last. Okay, well, it's just another way of defining this stack. So LIFO or FILO, they are just the same. Okay, last in, first out, or first in, of course, last out. Okay, so the order means data can be accessed only if it's at the top of the stack. Okay, so whichever comes at the end, that is the data, or that is also the one that can go out at the very first. Okay, so we have an example here. So to access the green ring, this one right here, the red and the yellow ring must be removed first. So you won't be able to go out. For example, this is you won't be able to go out unless the red one and then the yellow one will go out first. So you have to go out first before you can go out. Okay, so the same with these chairs, and then with this call this one badminton, lawn tennis, I think. So this is the ball for a lawn tennis. Okay, so we have a structure right here, the structure itself of the stack, a stack data structure. So we have some operations right here, the push, which is to add an item in the stack, and then we have the pop, which is a very common function that we're using to remove or to delete an item. So this one is to remove an item from the stack, and then empty returns whether the stack is empty, and then we have the size. This one returns the size of the stack, and then we have the top, which returns a reference to the topmost element of the stack. So we have here the stack data structure, so we can only add, from starting from the bottom up to the top. So whichever is the last one, then that is the last place that we can, put our data. So we cannot put it inside. I mean, we cannot put it at the middle or at the bottom. So we can only, add data at the very top. Okay, and at the same time, we can also only pop, or we can also only remove data at the very top. Okay, so we cannot pop the data at the middle. Well, of course we can do that one, but that is not a stack anymore. That's a different uh, structure already. That is not a data structure anymore. If you're going to remove that data at the middle or at the very first data, or at the very low end data. Okay, so we have here some examples on how to add and how to remove or how to pop. So to push an item into the stack, use append function, and to pop an items out of stack, so use pop. So I think this is a very straightforward example. We have here a stack which is an empty stack for now, and we have here the first data that we are going to add, or we are going to append. So stack that append, and then this string right here. So this one, append adds item at the end of the list, or the top of the stack. So of course, since this is an empty data, so the top one is of course the lowest portion, which is this one. Okay. And here is the second data, which is of course stack that append, and then another string which is world. So we now have here the hello, and then followed by the world, and then followed by the another data which is a computer. So if you're going to print this one, of course, we'll start from the very bottom, and then followed by the next one up to the last one. So we have here hello world computer. So we have here another function which is we can remove or delete a portion of a data at the very top. So stack.pop. So this one removes item at the end of the list. So whatever is the last one that we have inserted, and that is also the one that will be removed. Okay, so if you're going to get the result of this one, so as you guys can see, the computer was now removed. Okay, and the good thing here in stack is that this one doesn't go back from the very start, wherein it will print everything, and then it will just simply remove just one data. So as you guys can see, we have already removed one data right here. Then we want to, let's say, remove another data, then just put here another function, let's say stack.pop. Then the world, or the latest previous data will be also removed or will be deleted. So as a result, this world will be deleted, and then we not only have the hello as our result. Okay, and then to get the size of the stack, so you can use len. So this is a very common function. So by now, I hope you guys already know what does a len function do. And then of course, with the combination of if statement to check if the stack is empty. So we have another stack here, which is an empty stack, and then we have appended 3, okay, starting from the hello world and then computer. And then if you're going to print that one, of course, you will have this one as your very first result. And then if you want to check how many data we have in that stack data structure, then just use this function print len and then stack. Okay, and then it will give you 3 datas, because we have, this is the first one, this is the second one, and then this is the third one. So that is why we have 3 right here as a result. And then by the combination of if statement and then the len function, so we can check whether the stack is already empty or not yet. So here, if len stack is equal to 0, then print true, else print false. So as you guys can see, we have 3 datas. Okay, that is hello world and then computer. Then of course it will give us a false result. Okay, so I think overall this one is a very straightforward example. So you might want to test this one on your PyCharm, or to your Visual Studio, or to your PyCharm itself. So yeah, just feel free to that one, so you can confirm if you really have the, this results or no. Okay. Okay, so we have another example here. So in this example, this is to check the top value without removing it from the stack. So you can use this one, index minus 1. So we have the same empty stack, and then the same data inputs. And then just if you want to check the very last inputted data, then just use this one, print stack and then -1. So this will give you the very last data that was inserted on that data or stack data structure. So as you can see, as a result, this will give you computer, since that is the very last stack that was inserted. Okay. So this one is just the print out of everything. Okay. So as it's just showing here that we didn't remove this one. Okay, it's still in there. Okay. So we have an important notice right here. So there are other ways to implement stack in Python using other built-in data structure, but for this module, we will be using the basics only. So we have here some, stack applications, which is maybe really useful when it comes to these kinds of situations. We have balancing of symbols. We have the infix, postfix, or prefix conversion. We have the redo undo features at many places like editors or Photoshop. We have the forward and backward feature in web browsers. So as you guys may already know, we love to use Control Z, or what is the redo? I don't know the shortcut for the redo, but for the undo it's Control Z. So that is the application that is being used, okay, in that kind of situation. So we use stack for that one. Okay. And we have here the forward and backward feature in web browser, similar with that one. So we backward this one, so the previous let's say history, or the previous website that we have visited, or the previous things that we did, okay, in our browser, will go back to that state. Okay. So we have here a sample problem using stack. So problem 1, convert the given prefix to infix form. So we have this prefix form, C times plus AB minus CD. And then if you're going to apply this conversion right here, so we will get this one as a result. Okay, or let's just see that this is what we are expecting depending on your program course. So we can have a different infix result, but for this example, we will or we would want to have this one as our result. Okay, so a plus b times c minus d. So we're going to arrange this prefix into something like this with this infix. So we have the algorithm for this problem number 1. So it says to create an empty stack using list, allow user to enter the prefix in string format, read the prefix in reverse order, okay, from right to left. If the symbol is an operator, then pop 2 operands from the stack, and then create a string by concatenating the 2 operands and the operator between them. So we have this sample string, and then followed by the plus operand 1 plus operator plus operand 2 plus, and call this one the parenthesis, okay, that's being needed on both sides, okay, to close the operand 1 operator and then operand 2. Okay, so we can have this one as our result. Okay, operand, operator, operand, and then the parenthesis, and push the resultant string back to stack. So if the symbol is an operand, then push it onto the stack, and then repeat step 3 until the end of prefix expression. So we have here the solution. So just note that assuming all inputs are valid, so here is the input. So if we have this input, then we should have this output. Okay, so I already did this one on my PyCharm, so let me show to you guys the result. Okay, So we have the prefix times plus ab minus cd times plus ab minus cd, ab minus cd. Okay, so as you guys can see, it gave us the result, which is the same with this one. Alright, so that's pretty much it for the module 4 or module 4.0. So we have less important notice right here. So in stack, you are not allowed to access non-top elements, so you can only add or push item at the top of the stack, so just like what I mentioned a while ago. So let us now proceed to the module 4.1. So this is the continuation of our module 4. So in here we'll discuss the queue. So this is a kind of abstract data type or collection in which the entities in the collection are kept in order. So queue follows the following order. So we have here the Lilo or Lilo, and then we have here the Philo. Okay, so Lilo is last in, last out. Philo is first in, first out. So this is more ideal, of course. So you could say that this is quite unfair, for the stack, because you went in. I mean, you went first, but you're going out last. Okay, but in here, once you go in first, then you will also go out first. Okay, first in, first out. Okay, so the order means data can be accessed only if it is at the front of the queue, while data can only be added in the queue at the where. So we have this one as an example. Okay, so this is the let's say the front, and then this is the rear. So if you're going to add, of course, it will be at the very last only, and then if you're going to delete or if you're going to remove, then that is at the very first only. Okay, or at the very front only. Okay, so we have here a more clear data structure of our queue. So we have here the deletion or the front. Okay, and then this is the rear where we can insert. Okay, so we have here a queue operations. So for the adding, we call that one enqueue. So this one adds an item in the queue. For the removing, we call that one the queue. So this one removes an item from the queue. And then empty, size, and then this one is actually quite similar also with our stack. Okay, so empty, size, but instead of top in the stack, at queue we call that one front. Okay, so quite similar with our previous data structure. So just like the stack, queue in Python can be implemented using a list. So to push an item into the queue, use append. So the same, if you're going to add an item, so this is called enqueue, but same, we're going to use append to add an item or a data on that structure or list. So to pop an item or to remove an item, of course, we're going to use pop, but instead of pop only, we have to add this 0 right here. Okay, so pop 0 function. So we have here an example for the queue. So queue is equal to an empty list, and then we have the same inserted data. We have the hello, world, and then computer. And then if you're going to print that one, of course, it will give us the same result or a similar result from the stack. So hello, world, computer. And then if you want to remove, so don't forget the if you want to remove a data, so don't forget the 0. So we have here pop 0. So queue that pop 0. So meaning you are removing the first data. Okay. So as you guys can see, the hello was already removed. So we now only have the world and computer as our result. So the same it stack. Okay, so we've deleted one data. If you want to delete another data, then just put here another function of pop. So q that pop, okay, which is the latest now, or the one that is at the front is the world. So if you're going to print this one, we now only have computer. Okay, so I guess this is a very straightforward example also. So to get the size of the queue, so it's actually quite the same. Use len function and if statement to check if queue is empty. Okay, so everything is pretty much the same. Okay, except for the variable that was used. So in here we use queue, and in here we use stack. Well, actually either way, you can just change this one into any variable name that you want. The only difference is that if you want to remove this, don't forget this 0 right here. Okay, and then if you want to add, of course, just use append. So it will be added at the very last. So similar with stack, it will be added at the very last. So the only difference is that if you're going to delete or if you're going to remove, you have to put this 0 right here. Okay, so this is actually like uh, not a notepad. So we have here, let's say, stack. So sorry for my handwritten since I'm just using a mouse. So let's say this is your array. Say we only have 4 arrays, 1, 2, 3, 4. So the same with you, we have 4 arrays, 1, 2, 3, 4. Now both of them are lists. This is a list, this is also a list, or you could say an array. So you could call it any uh, data structure that you want. So list or array, same. So we have here the first array, let's say 0 array, 1, 2, and then 3. Same, 0, 1, 2, and 3. So by default, if you're going to add, okay, you're going to use append, it will always go to the very last. Okay. So if you're going to pop, by default, it will pop the very last. Okay. So in queue, since we have to follow the algorithm we're in, first in, first out. So there is an additional thing wherein we have to pop the very first array. Okay, that is why we are adding that 0 right there, because we wanted to delete this first array. Okay, and then that makes this one as a queue, since that is the one that is being deleted, the rare. Okay, so not the last one. So that's the main difference between the stack and then the queue. Okay, so another thing is that, where is that? So later on we'll discuss the on how to retrieve the very last, or the rear, or front. So we'll discuss this one later after this len and then if function. So again, the same, we have empty stack, the same inputted data in our queue stack, okay, or queue data rather. So we have here the first output, so hello world computer, and then it's just checking how many data we have in here. So of course we have 3, and then it's just checking if it's empty, okay, or no. Of course it's not empty, so of course it will give us a result of false. And then we have here to to check the value of the item in front of the queue without removing it. So the same. Okay, so if you want to check the very first data, so instead of queue only, okay, so we have to add 0, since we are now getting the front, okay, or the very first data. So let's compare that one right here. So in here we have a -1. So as you guys can see, we have 0 as the front. Okay, so regardless stack or queue. But in here, if we want to get the very last, so we have to use -1. So let's say stack. Here's my pen. Why is it not working? Okay, so oops, there you go. So in stack, if we want to get the very last data, we have to use -1. Okay, so meaning we are accessing the very last data. But since in queue we can only check the front data, so we have to use QUEUE 0 for that one. Okay, so this is what you are trying to check. So stack, we're always checking the very last, and then queue, we're always checking the first one. Okay, that was inserted in our data structure. So those are the differences. Okay, so 0 to remove, and then -1 to check the last one for the stop, and then 0 for the queue. Okay, so that is why uh, you know they are quite similar with each other. It's just that the variable and then the 0 and then 1s when it comes to accessing a specific array, first or last, something like that. So an important note is that there are other ways to implement stack in Python using other built-in data structure, but for this module we will be using the basics only. So similar to the not this one, my apologies. Okay, so well, actually quite the same. So there are other ways to implement queue, okay, instead of stack. So there are other ways to implement queue in Python using other built-in data structure, but for this module we will be using the basics only. So here are some uh, useful functionality of a queue. So simulation and program sets, serving requests on a single shared resource like a printer or a CPU task scheduling, etc. And then handling of interrupts in real-time systems, and then the interrupts are handled in the same order as they arrive. For example, the first come, first serve. Okay. Well, actually, this one is 100% exact with the first come, first serve. So it's just that it has a different term, which is the first in, first out, or FIFO. Or in operating system, we call that one FCFS, or the first come, first serve. Okay. Anyway, so we have here an example or a sample problem using EQ. So problem 1, simulate round robin CPU scheduling. So we have the requests. So we have 5 requests starting from the very start up to the last, and then we have here the burst time, or say how many milliseconds or how many seconds before that process will be finished. So we have, let's see, 8 seconds, 4 seconds, 9 seconds, 5 seconds, and then 2 seconds. So round robin scheduling is a process wherein each process is assigned a fixed time slot. So we call that one quantum time in a cyclic way. So assume that order of requests is from P1 to P5. And then quantum time is 4 seconds. So burst time is in seconds. Display the order of the requests accomplished. So the result of this one is actually P2, P5, P1, P4, and P3. So how did we arrive with this one? So let me explain this using a paint. So we have here, I think it would be more decent if we're just confused. P1, P2, P3, P4, P5. So we have here 8, 4, 9, 5, 2. 8. Why can't I use the space? What happened? Oops. Redo. Why was the redo not working? Anyway. How can I delete this one? Crap. Okay, anyway, let's move right here. Or let me just open a Q1 paint. So a text P1, P2, P3, P4, P5. That is 8495 8 4 9 5 2. So in round robin, it follows the first come first serve algorithm. So we have a burst time or a processing time on each of those processes by 4 seconds. Burst time is equal to 4 seconds. So meaning this is the time that we can allot for each process. Then after 4 seconds, we have to move on to another process, and so on and so forth. So in here, so what we'll do is we will follow the same order, of course. P1, P2, P3, P4, P5. And then in here, so 8 minus 4. So it already processed 4 seconds of this one. So we have a remaining of 4 seconds. So that is for the P1. So we have to go back on that one later. So for the P2, 4 minus 4 is 0. So meaning this second request or second process is already done. So if that is the case, let me just put it right here. Already finished. Okay. So P2 is the first one that was finished. So P3 is 9. So 9 minus 4 is 5. P4 is 5. So 5 minus 4 is 1. P5 is 2. So that 4 seconds is super enough already. So let's just say this is 0. So as you guys can see, we have another finish process here or request. So this is the second one that was finished. So P2 followed by P5. So let's move on to another cycle. So this is the first cycle. P1, P2, P3, P4, P5. So going to the second cycle. So 4 minus 4 is 0. So we can actually write it here already. P3. And then P2 is already finished. So we can just simply put X on that one. P3 is there's still a remaining 5 seconds that needs to be allotted. So 5 minus 4 is 1. So we cannot write it here for now. Oops, why is this P3? My bad. This one should be P1. This one right here. And 1 minus 4 seconds is of course already 0. Then we can already write that one here. P4. For the P5, it was already over at the first cycle. So as you guys can see on the third cycle, it's already obvious that this one is already over. And P3, 1 minus 4 is of course already 0. So with that, let's just write here P3. So we have here an order P2, P5, P1, P4, P3. So it's like, what happened here is that once it's already equal to 0, it will be popped. Okay. So P2, P5, P1, P4, P3. P2, P5, P1, P4, P3. So we have the same result. So that is why this is the answer for this round robin CPU scheduling. So we have this algorithm. So add all requests into the queue in order of arrival, and create a list for burst time and another list for the request name, and then check the value of the front index. So do not pop yet. Okay, just check that one first and read its burst time. So let's just say BT for that one, and then perform BT minus Q. So Q is the quantum time to identify the new burst time. So if new burst time is less than or equal to 0, perform the Q. So what is the Q? It's removing or popping that data, and create a new string. See, variable string is equal to string plus double apostrophe plus the Q element, and then what is the name of that one or request name. Else, then add the queued element back to the queue and update the burst time. Okay, so repeat steps from step 2 until queue is empty. So quite similar in the example in our stack. And then display the string. So we have here the solution. Okay, so request BT and then a request, etc., etc. So we have 5 queues, and then in here it will be printed is 1, this label right here, this P1, P2, P3, P4, P5. So as you guys can see, we have 5 for the range starting from the 1 of course. So that's how this 1 is being displayed: P1, P2, P3, P4, and then P5. And then once we're done with this, while function, it will print the string order. So as you guys can see, we have P2, P5, P1, P4, and then P3, which is the same with this one. Okay. So I actually tried this one. Of course, I tried this one on my PyCharm. However, I'm getting an error for this one. I did check everything, and then everything is the same. So I don't know what's wrong with my code, or with this code. I don't know if this is really working, because it says here this is the expected output. We have this one as the input, 84952, and then the blue one is actually the output. So I actually tried that one, 8 for the first one, 4 for the second one, but upon putting the second value, so it's already giving me this error. So I searched for a solution, but I cannot find an exact solution for this one, or a similar problem. So some of them is just quite the same, but this is giving me an option to change that int into float, but that doesn't work in this example, or in this solution. So I tried removing this int right here, and then it will just accept any input instead of integer only. 8, what is it, 1, 8, 4, and then 9. But as soon as I put the third value, this 9 right here, it is already printing the first two results. This one, the 849, P1, P2, P3, P4, and then P5. But it won't let us proceed to this function wherein it will display the string order, which is the P2, P5, P1, P4, and then P3. Okay. So yeah, it says here another problem, or another error with the DT-4. So I don't know what's wrong anymore, but yeah, this is where I was stuck. So I cannot find a way to make this one work anymore. So I would like you guys to test this one out also, and then let me know what's wrong with this code. Okay, or did we miss something? Okay, did I miss something? Or maybe this code is not just really working. Okay. And yeah, that's actually it for the queue. So another important note is, so in queue you are not allowed to access non-front element. So you can only add item at the rear of the queue and remove from front. Okay. So that's pretty much it for this module. So please let me know, guys, if you were able to make this one work on your own desktop or terminal. So that would be all for this module, for module 4 and module 4.1. So goodbye. See you guys to the next video. Peace.